The next one is very important notice. That is the electronegativity difference between two elements. Suppose A is greater than 1.7, then that compound is having ionic character. Ionic character. This one is, remember students, this is very important for competitive side. Then very important one is lattice energy. So nowadays lattice energy means lattice energy is formed during the ionic compound. Ionic compound. What is lattice energy? The amount of energy released during the 1 mole of ionic compound. The amount of energy is released during 1 mole of ionic compound from their gaseous cations and anions. That is called lattice energy. Lattice energy. And here lattice energy is directly proportional to the product of charge on cations and anions. Here Z plus and Z minus indicates charge on cation and anion. Cation and anions, and inversely proportional to sum of the radius of cations and anions. Okay. This formula is very useful. And one more point in that lattice energy. How the lattice energy is calculated? It is calculated based on Born-Haber cycle, and that phenomenon is depends on S law. Already you know S law, thermodynamics law only. Then characteristic properties of lattice energy. Characteristic properties. First property is lattice energy is increases by the decreasing of size of cation and anion. So remember this condition. Here I am taking one example: lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. In these compounds, which one is having highest lattice energy? Once observed, here anion is same in these compounds, but cations, that is central atom, is different. Central atom is different. So here, which one is a smaller cation? Already I told here, lattice energy is inversely proportional to size of ion. So the cation is here, the cation which having smaller in size in their compound, that one having a more lattice energy. So in this one lithium chloride is more lattice energy than sodium chloride, than potassium chloride, than cesium chloride. Remember, very important this condition. Second one is, suppose lithium fluoride, lithium chloride, lithium bromide, lithium iodide. In this condition, once observed, which one is constant? Here lithium is same in these 4 compounds, and side. Now once fluorine, chlorine, bromine, iodine. This one is different. So here anion is different in these 4 compounds. Which one is smaller anion? Which one is bigger anion? So smaller anion is fluorine and bigger anion is iodine. So in this one, based on this condition, lithium fluoride is having more lattice energy. Then order is like this: lithium fluoride greater than lithium chloride greater than lithium bromide greater than lithium iodide. So this one is very important condition. Then next condition is the next characteristic property of lattice energy is lattice energy is depends on the charge on ions. That means greater the lattice energy is more the charge on ions. That is, charge on ions is increases, the lattice energy also increases. Suppose I am taking one example, NaCl, MgCl2 and AlCl3. In this condition, once observe, +1, +2, +3 charge. Here +1, +2, +3. So which compound is having a high charge? So here AlCl3 is having more charge, then that compound having more lattice energy. More lattice energy. And one more condition is, greater the lattice energy, more is strength, and stability also is more, and melting point is also more. But their solubility is low. Solubility is low. Once observed in this condition, above condition, stability, I am writing. Stability, order, and solubility. Order. I am taking this example again here. Lithium chloride, sodium chloride, potassium chloride, rubidium chloride. Lithium chloride, sodium chloride, potassium chloride, rubidium chloride. So here, once observed, what is the stability order? Before that, we should decide lattice energy. So what is it here? Lattice energy is directly proportional to strength, stability, and melting point. So which one is more stable? Lithium chloride, than sodium, than potassium, than rubidium chloride. So stability order is like this. And here solubility is reversed. So which one is more soluble? Rubidium chloride is more soluble. So these are very important characteristics of lattice energy. Okay, here this is today's class. Tomorrow class we will discuss next topic. Thank you.